Hello and welcome to our channel. If you're a navigator, a maritime student, or just interested in how modern ships get from A to B safely, you're in the right place. Today, we're diving deep into one of the most critical tasks on the bridge, creating a passage plan using an electronic chart display and information system, or ECDIS. Passage planning, or voyage planning, is the backbone of safe navigation. It's all about ensuring the vessel moves safely, efficiently, and in an environmentally friendly way. With ECDIS, this process has become incredibly advanced. We're talking automatic chart updates, real-time sensor data, sophisticated alarms, and much more. But here's the thing, technology is a tool, not a replacement for a skilled mariner. Even with all this automation, the ultimate responsibility for planning, checking, and executing the voyage rests firmly on the shoulders of the bridge team. This isn't just good practice. It's a requirement under major international conventions like SOLAS, SDCW, and MARPOL. These rules all stress the importance of safe navigation and the human element. So, in this video, we're going to break down the essential parameters you need to set up in your ECDIS to create a robust and compliant passage plan. We'll go through it step by step, making sure you understand not just the what, but also the why behind each setting. Let's get started. First up, before you even think about dropping your first waypoint, you need to configure your ship's static and dynamic parameters. This is the foundation of your entire plan. Think of it as telling the ECDIS exactly what kind of ship it's dealing with. You'll input static data like the ship's length, beam, and gross tonnage. This information usually doesn't change. Then you have dynamic data, which can change for each voyage. This includes the ship's current draft fore, aft, amidships, and the air draft, which is the vessel's highest point above the waterline. Getting the draft right is absolutely crucial. An incorrect draft value could lead the system to miscalculate under keel clearance, putting you in a very dangerous situation. Now, let's talk about safety settings. These are the virtual guardrails that will keep your vessel out of trouble. The most important of these is the safety contour. The safety contour is a line on the electronic chart that separates safe, navigable water from unsafe water, based on your ship's draft and your company's policy for underkeel clearance. For example, if your ship's draft is 10 meters and your company requires a minimum underkeel clearance of 2 meters, you would set your safety depth to 12 meters. The ECDIS will then highlight the 15-meter depth contour, as it's the next deepest contour available on the chart, and you must not cross it. It's your primary visual cue for danger. Next is the safety depth. This parameter works with the safety contour. You set a specific depth value, again, based on your draft and required clearance. The ECDIS will then use this to color code the depth soundings on the chart. Any sounding equal to or shallower than your safety depth will appear in a bolder font, making them stand out. This gives you a quick, at-a-glance reference to potentially hazardous shallow spots, even within your safe water area. It's a secondary layer of safety. Then we have the shallow contour and the deep contour. The shallow contour is set to a value less than your safety contour, typically equal to your ship's draft. It highlights areas that are definitely too shallow to enter. The deep contour, on the other hand, is set to a deeper value, often double your draft. The area between your safety contour and the deep contour is usually shaded in a light blue or grey, representing the navigable channel you want to stay in. The area between the shallow and safety contours is shaded darker, warning you to stay clear. Together, these 4 contour settings, shallow, safety, deep, and the 2 shade depth setting, create a clear visual pathway on your screen. Once your safety parameters are set, it's time to start building the route. This involves placing waypoints from your departure point to your destination. When you're placing waypoints, you need to be strategic. They should be placed at every course alteration, at critical points like the start and end of a traffic separation scheme, or when passing a significant navigation mark. Each leg of the route, the line between 2 waypoints, needs to be carefully considered. For each leg, you need to set the cross-track distance, or ECDIS. This creates a safety corridor around your planned track. If your vessel deviates beyond this set distance to port or starboard, the ECDIS will trigger an alarm. The value you set for ECDIS depends on the sea room available. In open ocean, you might set it to 1 nautical mile, but as you approach coastal waters or narrow channels, you'll need to reduce it significantly, perhaps to just 1 or 2 cable lengths. This ensures you stay precisely on track where it matters most. Another vital element for each leg is setting the turn radius. When your ship turns from one leg to the next at a waypoint, it doesn't pivot on a single point. It follows a curved path. You need to tell the ECDIS how tightly you plan to make that turn. The turn radius depends on your ship's speed, maneuverability, and the angle of the turn. Setting an appropriate turn radius ensures the ECDIS calculates the wheel over point correctly, that's the exact spot where the rudder needs to be applied to execute the turn smoothly and stay within the safe water corridor. Modern systems can even calculate this automatically based on your speed and rate of turn. Now, let's talk about integrating other crucial information. Your ECDIS is a powerful tool for information management. You should be adding manual updates and navigator's notes directly onto the chart. For example, if you receive a Navtex warning about a new wreck or a temporary navigation buoy, you can plot it as a manual update. You can also add notes for the bridge team, like call master 30 minutes before arrival or reduce speed to 12 knots here. These notes become part of the passage plan and are displayed at the relevant point in the voyage, serving as important reminders for the watch-keeping officer. Another critical overlay is the environmental data. You can import weather forecasts, including wind speed and direction, wave height, and ocean currents. The ECDIS can use this data to calculate your estimated time of arrival more accurately and can even help in optimizing your route for fuel efficiency and avoiding heavy weather. For instance, if a strong head current is forecasted, you might decide to alter your course slightly to avoid it. Or, if heavy seas are expected, you'll know to prepare the vessel accordingly. This proactive approach to weather routing is a huge safety and efficiency benefit. After you've laid out your entire route, from pilot station to pilot station, the job isn't done. The most important step is yet to come: route checking. Every single leg of your voyage plan must be automatically checked by the ECDIS. The system will scan the entire route against the electronic chart data and your safety settings. It will generate a list of potential hazards, such as crossing a safety contour, passing too close to a navigational danger, or entering a restricted area. You must review every single warning and alarm generated by this check. Don't just ignore them. Investigate each one. Is the alarm for a shallow patch that's actually well clear of your track? Or is it a genuine danger that requires you to adjust your waypoint? For example, the system might flag a wreck near your course. You'll need to zoom in, check the charted depth over the wreck, measure the distance from your track, and decide if you need to give it a wider berth. This meticulous checking process is your final line of defense against human error in the planning stage. Document your findings for each flagged item, explaining why you've either accepted the risk or amended the route. This is a key part of your due diligence. So, to recap the key steps: first, set up your ship's static and dynamic parameters, paying close attention to the draft. Second, configure your safety settings: the safety contour, safety depth, shallow contour, and deep contour. Third, carefully place your waypoints and define the parameters for each leg, including cross-track distance and turn radius. Fourth, add essential information like manual updates, navigator's notes, and weather overlays. And finally, the most critical step of all, perform a thorough route check and resolve every single hazard identified by the system. Creating a passage plan in ECDIS is a detailed and systematic process. It combines the power of technology with the skill, knowledge, and judgment of the professional mariner. By diligently setting these important parameters, you are not just ticking boxes. You are actively building a framework for a safe and successful voyage. It's about being proactive, not reactive, and ensuring the safety of your crew, your vessel, and the marine environment. Thank you for watching. We hope this guide was helpful. If you found this video useful, please give it a thumbs up, and don't forget to subscribe to our channel for more content on maritime safety and navigation. Safe sailing, and see you in the next video.